Okay, so for steps 5 through 7, or for step 5, I watched the 5 YouTube videos and jotted down a couple notes on each one. So for the first one, basically what we're doing is just determining the average airflow or the air speed through the wind tunnel without any flow restriction or objects. So basically you just got to start the wind tunnel, make sure your measuring device is perpendicular to the fan, and then you want to take 3 measurements in each corner so that you can determine the average wind speed in the whole thing. And then in the second video, the same measurements were done, but this time there was a flow restrictor to change, basically to change the wind speed. And then in the third video, we started measuring the drag force on the objects. So they started with a sphere, made sure to put the 2 rubber bands on it so that we could attach the fishing line, and then they hung the ball up in the wind tunnel, placed it against the force sensor, and then turned the fan on to get the force reading from each piece with different wind speeds. Yep. And then video 4 was the exact same as video 3, just using a cylinder now, and then they took the measurements from 2 different profiles. So one was basically a rectangle and then the circular area of the cylinder. And then video 5, same thing, except this time it was just a block. And again, they took the reading from a small area side of the block and then a large area side of the block. So then for step 6, I just showed the first couple calculations I did by hand here, and then the rest will be on Excel. I'll pull that up after, but basically to figure out the force on each profile, you just got to take the density of air multiplied by the cross-sectional area of the object multiplied by the wind speed squared. That equation came from the book, chapter 14. So here you can see for the sphere, I just did a couple. For the 1.1 wind speed, plug all this stuff in. Here's the area of the circle, and come up 1.751 times 10 to the negative 3 newtons. Same thing for 3 miles an hour, all the exact same except the wind speed is different. And for that one, come up with 0.013 newtons. And then the rest I just did on Excel. So you can see all my calcs here. For each shape, for each profile, we calculated the cross-sectional area and then listed the wind speed for each one. And then here you have the same equation, just here's the density of air, 1.293 kilograms per cubic meter, multiplied by the cross-sectional area times the wind speed squared. So you can see we came up, our first 2 are the same, and then the rest from there are all good. I also listed the measured force next to everything just to keep it neat. And then, still have that one on, but basically to get the linear function for each one, I just created a scatter plot of each with a line connecting them, and then for each one of these 7 or 6 different profiles, I went through and added a linear trend line and just took the equation from there, entered it here. And that is pretty much everything I did.